Hi everyone, welcome to the presentation on software engineer versus programming. These two terms often get mixed up, but they actually describe different roles and responsibilities in the world of technology. In this video, we'll explore what programming is, what software engineering is, and how they connect to form the foundation of modern software development. By the end, you'll understand how programmers and engineers work together to turn ideas into real-world systems. Let's begin with programming. Programming is the process of writing, debugging, and testing code to perform a specific task. A programmer focuses on syntax, logic, and algorithm design, the step-by-step instructions that tell a computer exactly what to do. Languages like Python, Java, and C++ or Kotlin are the main tools used by programmers to bring ideas to life. You can think of programming as the craft of turning abstract concepts into working software, whether it's a small app, a calculator, or part of a bigger system. So, what exactly is software engineering? It's the application of engineering principles to the development of software. Software engineer covers the entire life cycle, from designing and testing to deployment and maintenance. It uses structured methods, documentation, and teamwork to build reliable, scalable, and high-quality systems. While programming focuses on writing code, software engineering ensures that the whole project stays organized, efficient, and sustainable over time. In short, programming is one part of software engineering, but engineering manages the entire process. Here's where we directly compare the two. Programming focuses on building functional code, writing the actual instructions a computer follows. Software engineering designs, integrates, and manages the entire system. Programming solves immediate problems. How do I make this work? And engineer plans for the future. How do we make it this last? You can think of programming as building blocks, while engineering is designing the entire building. One can exist without the other. Together, they create functional, long-lasting software. Software engineering is a team effort. It involves programmers, designers, testers, and project managers all working together. Collaboration happens through frameworks like Agile and Scrum, where work is divided into small, manageable sprints. Teams use tools like Git for version control and Jira for tracking process. Strong communication keeps the workflow smooth and ensures everyone stays aligned on project goals. That's what makes software engineers so powerful. It combines technical skill with teamwork and organization. Before any code is written, software engineers design the system. In this phase, they define component boundaries, how modules interact, where data lives, and which technologies to use. Decisions like microservices versus monolith, which database fits the workload, and how services will communicate are made here. Engineers use UML diagrams, component diagrams, and common design patterns to make the architecture clear and reusable. Good architecture plans for scalability, performance, fault tolerance, and security upfront. Investing time in designing prevents costly refactors later and keeps the system flexible as requirements change. Next, we'll see how testing and maintenance keep the architecture healthy over time. After software is written, engineers test it to ensure it works correctly, securely, and efficiently. There are different types of testing: unit, integration, and user testing, each targeting different layers of the system. Once released, maintenance becomes a continuous process, updating the software, fixing bugs, and improving performance. This cycle of improvement is a big reason why engineer matters. It ensures software continues to serve users over time. Let's look at an example. Imagine you are creating a banking app. A programmer writes a code that allows users to log in, check their balance, and make transactions. A software engineer, on the other hand, plans how the data flows between the app and the bank's servers, setups, security protocols, and ensures everything scales as more users join. Both roles collaborate closely. The programmer focuses on getting each feature to work, while the engineer ensures the system as a whole stays efficient and secure. Together, they build a product that's both functional and reliable. When it comes to skills, both programmers and engineers need strong logical thinking and problem-solving abilities. Programmers focus more on coding languages, algorithms, and debugging, and software engineers need those skills too, but they also develop leadership, project management, and system design skills. Many engineers actually start as a programmers and later grow into engineering roles as they gain experience. In both careers, curiosity and adaptability are key. Technology changes fast, so continuous learning is essential. Let's wrap things up. Programming is about implementing code to solve specific problems. Software engineering is about designing entire systems that last and evolve. Both rely on teamwork, structure, and carefully planning. Together, they create reliable and scalable software that powers everything from our phones to space exploration. Without programmers, software can exist, but without engineers, software wouldn't survive. It's the combination of both that drives innovation. Thank you for watching this presentation on software engineer versus programming. I hope you now understand the differences, how they work together, and why both are vital in today's tech-driven world. If you're studying computer science or information systems, remember, mastering programming is the first step toward becoming a great software engineer.